All right, Commander, listen up. Welcome to Mission Control. This is your official survival manual for the M-U5K-3T project. Let's get right into it.
First things first, and this is the most important message you're going to get. See that? High latency? On this exoplanet, the delay is so bad that by the time you tell the rover to turn left, it's already a pile of dust in the bottom of a crater. Direct control? It's completely impossible. So we have to adapt. Forget the joystick, Commander. You're not a pilot anymore. You're a programmer. Your job is to give this rover a brain, a set of rules it can follow all by itself. Honestly, your code is its one and only hope for survival. Okay, so let's get you properly briefed. We've talked about how you'll operate. Now let's cover why you're even here. Make no mistake, the stakes are incredibly high, but the potential rewards? They're absolutely astronomical.
Everything on M-U5K-3T happens in what we call ticks. You can just think of them as turns. With every single tick, time freezes for a moment. The system runs your code, and then it executes the one and only one command you give it. Your code is the rover's brain, making one choice at a time.
And here's how you win. This planet is littered with priceless minerals. Your logic has to guide the rover to find every last one of them, all while dodging the 1,000,001 things that want to turn your very expensive piece of tech into a scrap heap.
So how in the world do you make these decisions when you're not actually there? Well, it all starts with what the rover can see. Let's talk about your eyes on the ground, the sensors.
But here's the catch, and this is a big one. You don't get some fancy satellite map or a GPS overview. Nope. Your rover only sees what's immediately around it. Think of it like a permanent fog of war. Every single decision is based on what you can see right here, right now. And the information you get is brilliantly simple. Your sensors give you one of three readings. Clear means you're good to go. Obstacle means, well, pretty obvious, right? Don't go that way. And mineral, that means you've just hit the jackpot. Your code's job is to take these simple signals and build a picture of the world.
All right, so your sensors have given you the intel. Now what? Your code has to choose an action. This is how the rover actually gets things done and interacts with the world.
You've got three basic moves in your playbook. You can move forward one space, you can turn where you're standing, or you can do a rotate and move. Now this last one is key. It's two actions, turning and moving, but it only costs you one turn. It's incredibly efficient.
And I'm going to say this again because it's the golden rule. One tick, one action. Choose wisely. Oh, and don't worry about looking for a collect button. The rover is smart enough to automatically scoop up any minerals it just drives over. Your job is just to get it there.
Okay, now this brings us to the coolest part of your entire toolkit. Seeing and acting is one thing, but how does a rover remember? How does it make a plan that lasts longer than a single turn? Let's talk about its brain.
So here's the puzzle for you. Your entire block of code runs from top to bottom, completely fresh, every single turn. So if you told the rover to turn left on this tick, how does it remember on the next tick that the plan was to now move forward? And the answer is context.memory. This is your secret weapon. It's a special little object that doesn't get wiped clean between turns. Think of it like a digital sticky note where your code can leave messages for itself to read on the next turn. This is how you build complex, long-term strategies.
So we've got the eyes, we've got the moves, and we've got the brain. How do all these pieces actually work together in a single loop?
It's actually a really simple, elegant cycle. Every single tick, your code first checks the sensors. Okay, what do I see? Then it checks its memory. Right, what was I trying to do? And based on those two pieces of information, it chooses an action. Then the next tick starts, and the whole thing repeats.
And really, that's the core of it, Commander. You have all the tools you need. Your mission is waiting. But before we send you off, here are a few final tips from us back at Mission Control to make sure you hit the ground running.
Pay attention. This part's important. 1. Never ever move forward without checking if it's clear first. 2. Efficiency is life out there, so use rotate and move as much as you can. 3. Keep an eye on your fuel and your health. And 4, and this one is absolutely non-negotiable, always test your logic in the danger room before you deploy.
The danger room is your local sandbox, your simulator. It gives you instant feedback so you can test your logic and see if it works. Deploy to orbit, on the other hand, that's the real deal. You send your code to the server, and it runs the mission for real. You can't touch it. You can only watch the replay and see if your brain was smart enough.
And this really gets to the heart of it all. You need to forget everything you know about driving a remote-controlled car. You are an architect of artificial intelligence. You're designing a brain from scratch and then letting it loose in one of the most hostile places imaginable.
That is the mantra of M-U5K-3T. Remember it. Sensors to see, memory to think, actions to act. Everything you need is right there.
The rover is ready. The planet is waiting. The only question left is, will the brain you designed be enough to survive out there? Good luck, Commander. Mission Control out.